Alright guys, the plan for today is we're going to start all my underground stuff. So I'm going to try to get my well line in, electrical line, and I got to dig around the sill plate here 2 foot down so I can get my insulation in and tamp all this stuff down, put number 2 stone in. So let's get right to it. I figured out pretty fast it's not fun to dig with a pickaxe and shovel at the end of February. The ground was still frozen, so it took a lot longer than expected. It got done, but it surely wasn't fun. If you're wondering why there's 2 sill plates in the back, the grade wasn't perfect when I put the building up, so we had to put 2 sill plates out back temporarily. Alright guys, I am sick of digging, so I'm going to start putting my 2-inch foam board around the sill plate here, and then I'll finish up digging after I do that. So the goal is to go 2 foot down and 2 foot out. That's for frost protection. It's a huge pain in the ass. If you're doing this, when you're putting your posts in, you should probably take a mini excavator and dig this beforehand so you don't have to do it with a shovel like me. But stay tuned, try to get this shit done, and then move on to the water line and that stuff. As you can see, I put the 2-inch foam on the inside of the sill plate. Looking back, I probably should have wrapped it around the outside. It would have been a continuous barrier. There wouldn't be the perma-columns in the way. Although in the long run, I don't think it's going to be that big of a deal. Still passed inspection, everybody was happy. So the foam board comes in 4 foot wide sections, and it's actually got a break down the middle, so it's pretty easy to split in half. I only have to go 2 foot down, so it worked out pretty good. The foam board is the top of the concrete pad, so you want it pretty level with the bottom sill plate. Either that or slightly high, and you can go back and trim it later. Alrighty, so the next phase here, I got most of the inside insulation done. I just have this little piece left. So we're gonna be going 2 foot out with the insulation, and we're gonna slope it slightly down so the water doesn't pool up here. This step actually turned out to be quite a nightmare. I left ditches opened and they all filled with water, and it just started to become a huge mess, especially during this time of year. Everything's unthawing and didn't really work out so good. So make sure you guys plan, if you're gonna do a ditch, do the whole thing in one day and backfill right away. Alright, so as you guys can see, it's 2 foot out. It's butted right up to the bottom of my other foam board. And so you gotta go all the way around the house. It's kind of a pain in the ass, but like I said, I'm leaving a little bit of drop in this. You don't want water pooling up here. I mean, probably will anyways, but it's worth just putting a little drop in it. Yeah, I'm probably gonna put a little bit of fill in here so it doesn't move too much, and then backfill it with an excavator. There's a little bit of fill on the other side of this too, so it doesn't push my foam board inside. It's probably not a bad idea too, if you have a tamper or you want to rent one, to smooth out the area before you put the foam board down, because it does crack and break pretty easy if it's on a high spot, which I ran into quite a bit. So you have to make the area pretty flat before you put the board down. This process actually ended up taking me the most time out of everything in this video. It was probably a couple weeks, honestly, of digging the inside and the outside and putting all the foam board in. The next thing on the list was the well line. That has to be at least 4 feet deep. I'm in upstate New York, so obviously the frost line's pretty low. Once again, I should have waited for a nicer weather because it was a muddy mess. And as you can see, as the video progresses, it got worse. Once the trench was dug, we had to start rolling out the 300-foot water line. It's a 1-inch line, and I can't remember what it's rated for, but we sleeved it with 2-inch PVC. It's great for protection, and plus, if you ever had to pull in a new water line, it's kind of possible. I probably should have used a 3-inch, but I might be able to pull one in the future if anything ever happened. After I watched a couple of YouTube videos, I attempted to do the pitless adapter. I actually just fired up the well today, so I know it works now, but at the time I didn't know what I was doing. I thought I over-tightened it, so it's kind of a relief that I didn't. So the pitless adapter has two parts. One part you thread into the T you see there with 1-inch NFT threads. The other side has a O-ring and gasket and a brass fitting that tightens down and keeps it all in place. So the next step was backfilling everything except for 2 feet of this, because I ran my PVC schedule 40 and then under the driveway was schedule 80 for my electrical service, which I wish I would have dug a separate trench, because obviously if something happened to the water line I'd have to dig under. But it is what it is at this point. It's in and it should be all right. After I took care of the electrical line and backfilled that, I moved on to the well pump. So it was pretty easy actually. We just used the 1-inch water line that we had left over, attached it to the well pump. A friend at work actually gave it to me, and it turns out it works great. I think it's 10 years old, but it held up just fine. So right here we're wiring up the well pump. I just needed 12-2 for mine, and I had to use heat shrinks just so everything's watertight. The well pump is super easy to wire up, just 2 hots and a ground. After we got everything connected, we ended up dropping the pump. This would have been easier to have another person, especially since my well is 160 feet deep, but we got it. We thread the pitless adapter part onto the T-bar there that we made, and that's so you can sink it into the other end of the pitless adapter in the well. I ended up running this 1,100-pound tamper just to get the material rock solid before I put any number 2 stone in. I ended up putting a lot of number 2 stone in, more than recommended, which isn't a bad thing. It should really prevent my floor from cracking. After I got the subgrade all tamped down, we put in probably 8 or so inches of number 2 stone, and we left 7 inches of foam exposed because we still have to put down 2 inches of foam board. As you can see, I'm using a laser here just so I can make sure my grade's pretty damn close. I mean, I go over this again with a tamper just to make sure everything's compact and smooth as well. Alrighty, so all the rough-in plumbing's done. Pretty simple, just a 5x8 bathroom. Tub shower in the back, which I have to make a box out around that. Toilet, vanity, and then drain for the kitchen sink, and that will be a drain for the washer. Next step is doing all my electrical rough-in, so we'll get right to that. Traditionally, most people on a residential application just use Romex, but I wanted to pipe all my home runs to each room basically, and to the mini split disconnects that I'm going to place on the back of the house. The square D home line panels definitely aren't ideal for this because they have concentric knockouts on the bottom. I think there was only 4 or 5 that were 3/4, so I had to punch a couple out, but it turned out all right. All of it's going to be buried behind the wall anyways, so I'm not really worried about how it looks. I made sure I had at least 3 pipes in the kitchen, 1 for the electric range, and then 2 for additional circuits. I think I'm gonna need at least 6 home runs in the kitchen alone, so this is pretty important. The next thing on the list was to get the final compaction in here with this little tamper. I borrowed this from my uncle, and it took me about 3 hours to get it running one day, but once it started, it worked pretty well. Once we rolled out the vapor barrier, we had to cut holes in it for all the pipes. And once you cut a hole in this stuff, you gotta tape it with special vapor barrier tape. Plus, we went around and taped all the outside edges just to make sure we were completely sealed up and I didn't get any moisture in my slab. So I've made quite a few mistakes recently. I put way too much film here. I had to take all of it like back out, probably 1.5 inches with a wheelbarrow. That was fun, but the vapor barrier is finally in, and we're starting to do the 2-inch foam. After that is all I gotta do is radiant floor heat, put some metal grit in, and then it's time to pour concrete. This was actually one of the easier jobs I've done on the house, so basically you're just throwing 2-inch sheets of foam board down and trimming up around where you have to, mostly the perma columns and the pipes. I also tried to stagger the rows, so I started off each end with a 16-inch wide piece, and then the next end would be a 4-foot wide piece, just so the seams weren't all in line and I didn't want any weak spots in the floor. After I cut all the holes around these pipes, I ended up going back with a little bottle of spray foam just to make sure all of that was patched up and there wasn't any spots for the concrete to seep in there. If foam is coated in your area, I ended up finding out that you can get foam board with the vapor barrier for just around the same price as this stuff online, so that's probably the better bet. So once I laid all the foam board down, I went through with a 4-inch thick vapor barrier tape. This stuff is super expensive, but it serves its purpose. It keeps the concrete from seeping in between the foam. For the radiant heat in the floor, I ended up going with PEX B and making loops with that. I was gonna go with PEX A, but it was a little on the pricey side, and I'm trying to stick to a budget on this build. I also got the Amazon radiant floor heat stapler and the uncoiler. It was a pretty good deal. It was cheap and it really helped out the process. So I have 5 loops overall, and I stuck with 6 inches off the exterior and 12 inches in between all the interior loops. I tried to stay away from any of the walls because I don't really want to worry about it when I'm drilling my tab cons down. After all the PEX was stapled down, we moved on to putting 1.5-inch chairs down and then dropping all of our, I think it was 5x10 mesh down on top of that, and I used tie wire to tie it all together. Okay, so as you can see, I mounted my manifold with supply and return for the PEX. I'm just gonna hook all my supplies up here and returns down here, and hopefully put a pressure test on it. I'm gonna keep the pressure test on when I pour the concrete, because if you nick one or something, you wanna be able to put a coupling in it right away. Obviously, if you bury it in concrete, that's not very good. After I completed the manifold, I ended up doing a quick pressure test just before the concrete, and I held 50 psi of air in it while I was pouring. This was my first time attempting a concrete pour, so it was kind of scary, but I got some good friends to help me with this, so it actually went pretty smooth. For the concrete, I got 4,000 psi with number ones and fiber reinforcement. This is going to be a finished floor, so I wanted to try to minimize the amount of cracking. I mean, it'll crack over time, but hopefully it's not going to be anything crazy. I finally have a concrete floor. I think that's going to wrap up this video. Probably going to make a couple more videos, framing and all that. I didn't do the best job recording every little detail, but it's something. Thanks for watching.